In today's video, we're going to be looking at the epiphyseal plate, which, if you remember, it's going to be the region of cartilage that is going to be growing in order to enlarge the bone. And it's going to be found in between the epiphysis and the diaphysis of our bone. Okay, so it's just a band of cartilage between the diaphysis, or the shaft of the bone, and the end of the bone, or the epiphysis. And it's going to have four layers of distinct characteristics. And the first layer is what we have up here in this picture. It's called the reserve zone, but this is going to be closest to the epiphysis. If you look here, so this layer is bordered by the epiphysis. And this layer of cartilage has cells that they're not multiplying, but this tissue is going to help to anchor our epiphyseal plate to the bone tissue within the epiphysis. And then the second layer, this is where mitosis is happening. So this is where all the action is happening within the epiphyseal plate. So we got a lot of young cartilage cells, chondroblasts, and they are multiplying, they're producing matrix, and both of those actions are going to thicken the plate. So it's going to get larger, okay, pushing down into the epiphysis, pushing down into the diaphysis. Our third layer is going to be the cells that are being pushed down by the mitosis that's happening up here in the second layer. So these cells are getting older, they're getting larger, and again, by producing more cells and more matrix up here and pushing down here, that is lengthening our plates and the entire bone as a result. And at this point, there are going to be some osteoblasts that are secreting calcium salts in this area. So the matrix is calcifying, as you can see here, and that is going to cause our cartilage cells to die. Okay, so at this point, now the matrix has fully calcified, the cells are all dead, and at this point, now we have just calcified matrix with dead chondrocytes. This is going to require some osteoclasts to come in to break down the calcified matrix here and then replace it with real bone tissue, and that would be the job of the osteoblasts. So the osteoclasts are going to break down our model here, the tissue that has produced in order to enlarge the bone, but it's going to need to be replaced by actual bone tissue, which has not just the bone matrix, but also our osteocytes and the organization of the lamellae or the trabeculae. Okay, so our bone is going to thicken, and what I mean by this is the diameter of the bone, not the length of the bone. So it's going to thicken as compact bone is deposited on the outside of the epiphyseal plate. Okay, like at the margins of the epiphyseal plate, compact bone will be deposited, and that makes our bone get thicker. At the same time, the osteoclasts are eroding the inside of the diaphysis to produce the medullary cavity, which is where marrow will reside. And then even at the end of all of the growth for our bone, hyaline cartilage is going to remain on the outside of the epiphysis where the bone would articulate with another bone. So this hyaline cartilage is a protective layer to prevent the grinding of the bone tissue from one bone to the next. Okay, and remember, that's going to be our articular cartilage. Okay, so if we take a look here, what's happening at the epiphyseal plate, new cartilage is forming up near the second layer, and that is going to push cartilage tissue down, the older tissue down. And the older tissue, as the cells are dying, is going to be replaced by real bone tissue, so the compact and the spongy bone. So a little bit about the osteoclasts, to talk about them more specifically, since we just talked about how they are responsible for breaking down the medullary cavity, the bone tissue to create the medullary cavity. So these are large cells, multinucleated, which means that they have more than one nucleus, and they're responsible for breaking down the matrix, not for building it up. So the clasts are going to do the opposite of the blasts. The osteoclasts will actually produce like an acidic, with some enzymes to break down the calcium phosphate and the collagen of the bone matrix. So these cells are responsible for breaking it down in order for osteoblasts to then build it back up. Okay. So the osteoclasts at our epiphyseal plate will break down the calcified matrix so that the osteoblast can come in and replace it with bone tissue. Okay, so the thing about these things is every time I look at it, it reminds me of something from a video game, a Metroid. So if any of you have ever played Metroid Prime, any of those games, you would know what I'm talking about. And it kind of makes sense because like in the game, these things actually break down and like absorb the life force from things, which is kind of frightening, but it's almost like the osteoclasts and these things do similar things because the osteoclasts are going to break down and resorb the bone tissue. And if you remember this may or may not be a bonus point question on the test, so something to remember. The osteoclasts look like Metroids, at least in my opinion. Okay, so bones are constantly being remodeled. So the process of these osteoclasts and the osteoblasts, they are active at all times. So there are two processes, and they are very highly regulated by hormones. And so resorption is when the osteoclasts are breaking down the bone matrix so that the calcium, the phosphate, collagen, so those amino acids, they can be resorbed or taken back, okay, and can be put back into circulation in the blood. That is especially necessary for the calcium and the phosphorus, okay. Deposition, that would be the opposite. So this would be the osteoblasts would be replacing the bone matrix. So there's a constant just resorption, so taking back the bone matrix and then putting it back with osteoblasts. So within a given year, on average, a person will have about 3 to 5% of their bone matrix exchanged. So 3 to 5% would be resorbed, and then 3 to 5% would be deposited again. So just kind of an interesting process happening here. But like I said, it is highly regulated by hormones, which we'll be talking about shortly. But before we get there, let's talk just briefly about some vitamins that affect bone health. And vitamin D is a very important vitamin for bone health because vitamin D is needed for the proper calcium absorption in the small intestine. So whenever you are digesting food and there's a lot of calcium in it, it doesn't necessarily mean that you're going to actually take in that calcium if you don't have enough vitamin D. So vitamin D is necessary for the absorption of your dietary calcium that you're getting from things like milk or other dairy products. But remember, vitamin D can be produced in the skin with a reaction with the UV light. But if you don't have enough vitamin D, then you're not going to be absorbing as much calcium. And as a result, the bone matrix that is being produced is not going to have as much calcium. So it's going to be softer and as a result, that might mean that the bone will actually deform a little bit if it's soft and not rigid. Okay, and then we have vitamin A, vitamin C, and vitamin K. Vitamin A is important for just the normal osteoblast and osteoclast activity. Vitamin C is important for the synthesis of collagen in the bone matrix. And then vitamin K actually helps to bring calcium in to your bones. So that is also very important, just like vitamin D. So these are some foods that you can eat that would be rich in each of these vitamins. And then obviously vitamin C, we know citrus fruits are one of the most important sources of vitamin C. And now we get to the hormones. So growth hormone is going to stimulate the mitosis at the epiphyseal plates. So that's going to increase the growth rate at the epiphyseal plate. So with the absence of growth hormone, which again is produced by the pituitary gland, if there is not enough or no growth hormone, then that leads to what is called pituitary dwarfism, where some of these bones would be not as long as they should be. An excess of growth hormone would lead to pituitary gigantism, so just an excessive lengthening of the bones. And if this happens once somebody is already an adult and the long bones are done growing for the most part, that can lead to what is called acromegaly, which is just the growth of hands, feet, and jaw. The thyroid hormone, known as thyroxine or T4, that promotes the formation of bone and bone tissue. Parathyroid hormone actually increases the activity of osteoclasts so that it breaks down the bone tissue so that calcium can be resorbed. And then testosterone and estrogen also play roles in the formation of bone. So it stimulates the ossification and the formation of bone tissue. And interestingly, estrogen's effect is a little bit stronger, which is one of the reasons why females go through puberty before males do, typically. So we are at the end of this video. So we have talked about the epiphyseal plates and some of the factors involved with the epiphyseal plates. I hope that you found this helpful. And then on Thursday, I will have a little bit of time for you to ask questions.